Reggie's Corner, we're going to look at solving linear nonlinear systems. So let's do a quick review. When you were just looking at working on linear systems, right? The number of solutions was the number of times that it intersected. So we have one solution. We had no solution if the lines were parallel, right? Because they never touch. And again, if they were right on top of each other, that would be an infinite number of solutions. So when we're working with these systems of equations, we want to know we could have no solutions or more solutions. So again, the real question is how many times do they intersect? And we're actually going to find out exactly where they intersect. All right, let's get started. So number one, there's a lot of algebra here. So in order to save some time, I got started. So let's look at this. We have a line right here, right? And this is an ellipse. So we're trying to figure out where the line and ellipse meet and how many times they meet. So what I did on this one, because again, you have to look at each system differently. I was able to use substitution and I got y by itself. Okay, so from here, I took my value that I have for y, that terms that I have for y, the expression, I substituted into y squared. Now from here, I have a binomial squared. So I wrote it out. Binomial times a binomial. I'm going to use FOIL, which I have right here. And again, distributed that 25 to all my terms, combined my like terms, and I ended up here. Now, again, as always, with the videos, if you want to pause them and try them on your own, that's perfectly fine. So from here, we had a greatest common factor, which was 18. So I factored that out. And then again, we're trying to solve, right? So we have to get our x by itself. So in the end, I got x is equal to 4 and x is equal to -3. So right here, 4 and -3. Now, I have to substitute it back in to really either equation will work to try to find my y values because I want to know the coordinates that where it's actually going to intersect. So this line is certainly easier to work with. So I rewrote when I had isolated y by itself, and now I'm going to substitute it in. So when I have y is equal to -0.6 times 4, right, we're going to deal with 4 first, plus 0.6, I end up with y is equal to -1.8. So that's one solution, 4 and comma 1.8. That's where it intersects in one spot. Now, if I do the same thing with my -3, so I have y is equal to -0.6 times a -3 plus 0.6, I end up getting y is equal to 2.4. So again, now I have -3 and 2.4. So there are the two spots. Now, again, what that will look like, let's do a quick visual. Here's my ellipse, and here's my line. Okay, so it's going to intersect. This particular system is going to intersect in two spots. And where does it intersect? Right there. All right, let's look at the next equations that we have. In number 2, I have a circle is my first one. And then again, my second equation, we have a subtraction there. So I know that's a hyperbola. So I have to figure out where they intersect, how many times they're going to intersect. So again, to give us a little bit of a head start, I rearranged my terms and substituted in there. I noticed that I have an x squared and a -x squared. So I used elimination. I got 2y squared equals 72, end up solving it. And I have so far y is equal to 6 and -6. Okay, so now again, I'm going to substitute it back in. I'm going to use my circle equation, just a little easier to deal with. So I have x squared plus 6 squared is equal to 45. X squared is equal to 36 is equal to 45. I'm sorry, plus 6, 36 is equal to 45. So x squared is equal to 9. So x is equal to 3 and -3. So this was when y is equal to 6. So what that means is when y is 6, it's going to be paired up. Oh, I did that backwards. When y is equal to 6, my x value is 3, and my x value is -3. Now I'll do the same thing when y is equal to -6. Substitute it in. And you'll see, as you're aware, that that's still going to give me positive 36. So in the end, when y is equal to -6, I'm still going to get 3 and -3. So I have 3 and -6, and -3 and -6. So in this case, the circle and the hyperbola are going to intersect in 4 spots. Let's do again, quick sketch. If that's my circle, a little bumpy there. My hyperbola is going to touch 2 times here and 2 times there, for a total of 4 times. Where do they intersect? These 4 points. All right, moving on to our last one for today. Again, we have another circle here. And this is parabola, right? Because we only have one term that has an x squared. So I'm going to space it out a little bit, and I'm going to use elimination again. So in order to do that, I lined up my terms. I'm going to multiply this by -1. So I have x squared plus y squared. Leave a little bit of space. I have 8, and that gives me negative x squared, which is what I wanted, minus 3y is equal to -10. This will zero out. So I have y squared minus 3y is equal to -2. Bring all my terms to one side. And then factor. So I have y is -2 and times y minus 1 is equal to 0. So because of the zero product property, I can set that up. So y is equal to 2 and y is equal to 1. So again, I'm going to try to figure out my x values, which is what I need. So I'm going to work with the parabola this time. So I have x squared plus 3 times y. The first one we'll do is 2. So this is when y is equal to 2, is equal to 10. So I have x squared plus 6 is equal to 10. X squared is equal to 4. So x is equal to 2 and -2. Okay, so again, when y is 2, here's I have 2 points so far, 2 and -2, and I'm sorry, 2 and 2. And then I have a -2 and again +2. Okay, now we have to do y is equal to 1. So let's do y is equal to 1. So I have x squared plus 3 times 1 is equal to 10. So x squared plus 3 is equal to 10. So x squared is equal to 7. So x is equal to plus or minus the square root of 7. Okay, so it looks like we're going to have two other points there. So I have square root of 7 and 1 and negative the square root of 7 and also 1. So when we draw this circle and the parabola, it's actually going to touch 4 times. So it'll be something like this. There's my circle, and my parabola is going to go through and touch it and go through again and touch it. So it'll touch somewhere in there, but it'll touch 4 different times. So it has 4 solutions. All right. Thanks so much for stopping by today. Have a great day.